What's going on, guys? Welcome back to another video, and today we have a video for Spelunker / Neuroglancer on how to spot a merger. Now, a merger is when a cell is connected to a different cell, and that is what we call a merge, and we want to make sure we have as few mergers as possible because we want these cells to only be the cell that they are and not a combination of more than one cell. So these can be tough, and they can range from easy to spot to almost impossible to spot. In this one, we're going to go over 3 spots, how I came across them, and the order in which I came across them, and then how I was able to identify them in that sequence. So when I open this up, you can ignore my point pairs, or not pairs, my points. That is where the mergers are, but we will get to them in the order in which I found them. So this was the first one I looked at. Now, the reason I was called to this cell was somebody was looking for the continuation of this area. Now, one thing you want to do when you continue something is make sure that what you're continuing is the cell that you're tracing and not a different cell. So it turned out that when I went over here, and this area is a little bit difficult to trace, so somewhat tactically, I decided to well, this is pretty difficult. Maybe this is a part of the cell, right? You create this idea in your head. If I can get rid of this, then that would be better for this cell. But also, you still want to find out where this path goes. If it's not the current cell you're working on, at least somebody down the line would be able to use that information. So it doesn't look like it goes that far. That also looks like a merger. And I believe that this actually doesn't really go that much. But because I was already in this cell, I decided to just give it a general proofreading, and I was able to find 3 mergers. So the first one is here. I'll just get rid of this. Now, this is a little bit strange to me, which is what cued me into, this sort of perpendicular line, this complete deviation from the trajectory that the cell was going to begin with. So I would believe that this cell would go like that. It can go up like this. That is true, but this perpendicular spot, it kind of made me think this is a little bit weird. They are similar sizes, so I was willing to believe, but after I investigated it, I could not unsee what I had seen. So as you can see, we're tracing, and we trace all the way over to there, and we're tracing it back, and then it starts to get a little tricky, right? So this path seems all well and good, but when we look at this path, we see a different story. So this neuron connects over here, right? And that is an indication of a merger. So keep your eye out for perpendicular things. So we tried to rule this out, but when we took a better look, looks like some goes that way, and this main branch goes this way. But this area here, you could see that there is a merger. So keep in mind, when you see stuff like this coming off, a lot of times, in this case as well, this is also a merger. And they add up, so you can get rid of that, you can get rid of this. That kind of ends there. But that got me curious to look around. I mean, there's other stuff like this, which can make it difficult to distinguish a merger because this is also perpendicular, right? So why isn't this a merger? Well, sometimes you just have to double check to see if it is or it isn't. This isn't as perpendicular, and you'd expect a branch like this, so that seems fine. This is clearly a merger to me. When it's thin like this and then it turns into a large structure that is very dissimilar than this branch, that would be a merger as well. These are smaller mergers, but as I said, they can add up, and sometimes these clues will lead you to much bigger mergers, right? So we check that part. Now we're going to check the opposite end of the cell. Probably get a continuation here. But one thing, so I found that one first, and then I found this one. So I was checking the tips here. This is a bit of a messy area, but again, this very thin connection to this much thicker branch, and then a bouton into a thin branch usually means that that's going to continue. If we turn that off, we can see where it goes. Was it this one? Yeah. So as you can see, that fits the shape and description of connecting to this place down here, which means it doesn't connect. So that would need to be disconnected, but then I started getting curious and I went back, and maybe you guys can tell from right here, but this branch and that branch are thicker than the branches they came from. And this was a big red flag, right? If the thickness changed from thin to thick, that is probably a sign that you've run into a merger. So I started at the thin area and I went up a little bit just to give myself some extra space to work with. I followed the path down, and then I got to this membrane swirl, and if we go slice by slice, you can follow it through. It remains continuous on the right side of the membrane swirl. We come out on this side. But then what's this? This, nothing to do with us. So where did that come from? It turns out connects to this pretty nicely. Fits the shape of that branch as well. And there, even though we found some thin, smaller mergers, we were able to use the same context clues to locate a very large merger. So from far away, a little bit hard to tell. And as you can see, if we rotate it like this, it's thin and then thick. But if you rotate it like that, it's thick and then thin. It's hard to tell from a distance these types of things because the branches can pinch and get very thin like that or very flat. But once you zoom in and you kind of get that macro look, it is easier to see the differences in thickness of branches. So those are some of the easier mergers to locate. The harder ones we call path swaps, and I will try to get video on path swaps for you guys in the next one. So hope this one was helpful, and I'll see you guys next time. Take it easy.